Okay, hi and welcome to GridMaths again. We're going to do just a random one to see how we use this method. Let's say we're going to have 237 times 793. Okay, so some annoying sum, all right? Something that looks horrible and busy. And let's see if we can do it with this sort of drawing the box method. Okay, so 237 times 793. Okay, so I'm going to just draw I'll just draw out the diagram. So this over here, across here, is going to be 237, right? It's going to be 237 along that way. And from there down to here, it's going to be 793. This is not to scale. Okay, so the first part's going to be 200. Let's say 200 to there. Okay, so let's say that's 200 there. Okay, that'll be 200. And then there'll be the 30 part, and then there'll be the 7 part. So let's just, it's not to scale, let's just do that. Boom. Okay, this one, boom, boom. Okay, so that's 237 times 793. So we'll just call that 700 from here to here, is that 700. Okay, so that's a 700. There's the 90 part, from there to there, and there's the last part. Okay, so I'll write it in. Okay. So, we got 237 across the top from there. From there, all the way to there is 237. Okay? And from here, all the way down to here is 793. We're going to do chopping it into 700 and 90 and 3. Okay? Now here we go, 700 by 200 is this whole area here, okay? 200 by 700, so 200 by 700, okay? Now the important part is 2 by 7, 2 by 7 is 14, okay? And the other part is we've got 1, 2, 3, 4 zeros, so we're going to have 1, 2, 3, 4 zeros. And the reason is because 100 times 100 is 10 times 10 times 10 times 10, okay, which is 100 times 100 is 10,000. So if in doubt, always count the zeros. 1, 2, 3, 4, 1, 2, 3, 4, okay, 7 gives 14. So it's 140,000, okay? That's that big chunk there, it adds up quickly, 140,000, all right? So the next chunk over here, this is 700 times 30. 700 times 30. Okay, so 3 sevens are 21, 21, and how many zeros? 1, 2, 3. So 0, 0, 0, okay? So 21,000, okay? That's a little comma, German comma. Okay, so 140,000, 21,000. This one here is 700 by 7, 700 times 7, 7 sevens are 49, so it's 4, 9, and 2 zeros. Oh. Okay, normally I wouldn't put the commas, but just here, just in case anyone's wondering. So 4,900, 21,000, 140,000, okay? So obviously this one is much, much larger. It's nearly 10 times as big as that, and so on. Okay, so that's the top three, and then this one here is 90 times 200. 90 times 200. Okay, 2 nines are 18, so it's 18. 1, 2, 3 zeros. 1, 2, 3 zeros. Because 10 times 100 is 1000, which is 1,000, so it's 1,000 times 18. Okay, so that's 18,000. I won't put it in the comma. This one here is 90 times 30. So 90 times 30. 3 nines are 27, so it's 27. How many zeros? 2 zeros. 10 times 10 is 100, so it's 100 times 3 times 9, so it's 100 times 27, so it's 2,700. Okay, this one here is 90 times 7. 90 times 7. 7 nines are 63, so it's 630. Okay, because it's got 10 times 7 times 9. Okay, this one here is 3 times 200. I don't really need to write it, but let's do it. 3 times 200 equals 600. 3 2s are 6. 2 zeros. This one here is 3 times 30. 3 times 30, which just equals 3 3s are 9, so it's 90. Excuse me, 90. This one here is 3 times 7. 3 7s are 21. Okay. So now we have 3 digits times 3 digits. So we have 3 times 3, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different pieces to add up. Okay. So we'll start with the small stuff. 21. 3 7s are 21. Okay. And write all these on different lines just to see how they all add up, and so it's manageable. Okay. Right, so let's say we've done that one. Okay, we've done that one there. 21. And we're going to have 9 different pieces here added up, which are all these things in circles. So 90, 21, 90, so 3 times 30 is 90. Okay, we've done that one. 3 times 200, 3 times 200 is 600. 600. So I've done that one, that one, that one. Okay. Then I do 90 times 7, 90 times 7. Okay. 90 times 7 is 630. So 630. Boom. Okay, 90 times 30 is, 90 times 7 is 630, 90 times 7 is 30, 90 times 30 is 2700, so 2700, 90 times 30, 3 nines 27 with 2 zeros, 2700, so we've done that one, that. Now we're up to 90 times 200. 90 times 200, which is 18,000. So 3 zeros, then 18. Imagine those as little zeros. And then we've done that one, and then we're up to the final one, which is 7 times 237. So 700 times 237. Okay, so this one here is 700 times 7. 700 times 7, 7 is 49, so it's 4,900. So it's 2. Okay, so it's 49. Okay, and then we have 700 times 30, which is 21,000. 21,000. And then we have 700 times 200, 4 zeros, 1, 2, 3, 4, and then 14. 1, 2, 3, 4 zeros and 14. 14, okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9 things. 1, 2, 3, 4, 5, 6, 7, 8, 9. So they're all there. So we just need to add all of these up. It's not that hard, okay? We might need a little space for if things overflow, like here we're going to overflow a bit, okay, into the next column, but that's fine. So let's use this one, let's use this line here for overflow, keep it blank for now, and we'll put the actual result in this line here. Okay, so that's all zeros, except for the 1. This one here is all zeros except for the 3, the 9 and the 2. So 9, 10, 11, 12, 13, 14. So 1, sorry, I made a mistake, 1 and 4. So the 1 carries. Okay, 9, 10, 11, 12, 13, 14. So I can put the 1 up here as a carry, but it's easy to write my carriages here. So 1, 4, 14. Okay, I've done that row, now I need this row. So there's a 6, a 6, a 7 and a 9. So 9 and 7 are 16. 16 and 12, what's 16 and 12? 16 and 12 is 28, is that right? So 9 and 7 is 16, and 6 is 22, and the 6 is 28, I think that's right. So it's a 28 plus that, so makes 29. Okay, and the 2 carries, right? 29, 28 from this thing here, plus the 1 makes 29. Now this one, 8, 9, 10, 11 and 4 is 15. Let's just check that, 8, 9, 10. 10 and 5 is 15, so it's 1, 5 plus the 2, so it's 15 plus 2, so it's 17. And the 1 carries, okay? This is the carry. Alright, so, and now we have this line here, 4, 5, 6, 7, and 8. No carry, and then the 1 from there. So, theoretically, that's the answer. And we can check it with a calculator, and I think we'd probably be right. So here you can see, you just make a diagram. It just needs to be big enough to write in the numbers. It doesn't need to be the scale. It's not, that distance there is not really 200, that distance there is not really 30, that distance there is not really 7, and so on and so on. So long as we have an area to write in each of our different pieces, okay? And you can use this for fractions, you can use it for decimals, you could use it for large numbers of digits. And it pretty much works out. Okay, so enjoy, and see you next time. Cheers.